History and nature, Mars the planet. Polar caps. Mars has two permanent polar ice caps. During a pole's winter, it lies in continuous darkness, chilling the surface and causing the deposition of 25 to 30% of the atmosphere into slabs of CO2 ice, dry ice. When the poles are again exposed to sunlight, the frozen CO2 sublimes. These seasonal actions transport large amounts of dust and water vapor, giving rise to Earth-like frost and large cirrus clouds. Clouds of water ice were photographed by Opportunity rover in 2004. The caps at both poles consist primarily of water ice. Frozen carbon dioxide accumulates as a comparatively thin layer about 1 meter thick on the north cap in the northern winter, whereas the south cap has a permanent dry ice cover about 8 meters thick. This permanent dry ice cover at the South Pole is peppered by flat-floored, shallow, roughly circular pits, which repeat imaging shows are expanding in some places and retreating in others. The northern polar cap has a diameter of about 1,000 kilometers, 620 miles, and contains about 1.6 million cubic kilometers, 5.7 by 1,016 cubic feet, of ice, which, if spread evenly on the cap, would be 2 kilometers, 1.2 miles, thick. This compares to a volume of 2.85 million cubic kilometers, 1.01 by 1,017 cubic feet, for the Greenland ice sheet. The southern polar cap has a diameter of 350 kilometers, 220 miles, and a thickness of 3 kilometers, 1.9 miles. The total volume of ice in the south polar cap, plus the adjacent layered deposits, has been estimated at 1.6 million cubic kilometer. Both polar caps show spiral troughs, which recent analysis of Sharad ice-penetrating radar has shown results from katabatic winds that spiral due to the Coriolis effect. The seasonal frosting of areas near the southern ice cap results in the formation of transparent 1 meter thick slabs of dry ice above the ground. With the arrival of spring, sunlight warms the subsurface and pressure from subliming CO2 builds up under a slab, elevating and ultimately rupturing it. This leads to geyser-like eruptions of CO2 gas mixed with dark basaltic sand or dust. This process is rapid, observed in a few days, weeks, or months, a rate of change rather unusual in geology, especially for Mars. The gas rushing underneath a slab to the side of a geyser carves a spider web-like pattern of radial channels under the ice, the process being the inverted equivalent of an erosion network formed by water draining through a single plug hole. History and nature, Mars the planet. Observations and findings of water evidence. In 2004, Opportunity detected the mineral jarosite. This forms only in the presence of acidic water, showing that water once existed on Mars. The Spirit rover found concentrated deposits of silica in 2007 that indicated wet conditions in the past, and in December 2011, the mineral gypsum, which also forms in the presence of water, was found on the surface by NASA's Mars rover Opportunity. It is estimated that the amount of water in the upper mantle of Mars, represented by hydroxyl ions contained within Martian minerals, is equal to or greater than that of Earth at 50 to 300 parts per million of water, which is enough to cover the entire planet to a depth of 200 to 1,000 meters, 660 to 3,280 feet. On March 18, 2013, NASA reported evidence from instruments on the Curiosity rover of mineral hydration, likely hydrated calcium sulfate, in several rock samples, including the broken fragments of Tintina rock and Sutton Inlier rock, as well as in veins and nodules in other rocks like Knorr rock and Wernicke rock. Analysis using the rover's DAN instrument provided evidence of subsurface water, amounting to as much as 4% water content, down to a depth of 60 centimeters, 24 in, during the rover's traverse from the Bradbury landing site to the Yellowknife Bay area in the Glenelg terrain. In September 2015, NASA announced that they had found strong evidence of hydrated brine flows in recurring slope lineae, based on spectrometer readings of the darkened areas of slopes. These streaks flow downhill in Martian summer, when the temperature is above -23 degrees Celsius, and freeze at lower temperatures. These observations supported earlier hypotheses, based on timing of formation and their rate of growth, that these dark streaks resulted from water flowing just below the surface. However, later work suggested that the lineae may be dry, granular flows instead, with at most a limited role for water in initiating the process. A definitive conclusion about the presence, extent, and role of liquid water on the Martian surface remains elusive. Researchers suspect much of the low northern plains of the planet were covered with an ocean hundreds of meters deep, though this theory remains controversial. In March 2015, scientists stated that such an ocean might have been the size of Earth's Arctic Ocean. This finding was derived from the ratio of protium to deuterium in the modern Martian atmosphere, compared to that ratio on Earth. The amount of Martian deuterium is 8 times the amount that exists on Earth, suggesting that ancient Mars had significantly higher levels of water. Results from the Curiosity rover had previously found a high ratio of deuterium in Gale crater, though not significantly high enough to suggest the former presence of an ocean. Other scientists caution that these results have not been confirmed, and point out that Martian climate models have not yet shown that the planet was warm enough in the past to support bodies of liquid water. Near the northern polar cap is the 81.4 kilometers, 50.6 miles, wide Korolev crater, which the Mars Express orbiter found to be filled with approximately 2,200 cubic kilometers, 530 cu.m, of water ice. In November 2016, NASA reported finding a large amount of underground ice in the Utopia Planitia region. The volume of water detected has been estimated to be equivalent to the volume of water in Lake Superior, which is 12,100 cubic kilometers. During observations from 2018 through 2021, the ExoMars Trace Gas Orbiter spotted indications of water, probably subsurface ice, in the Valles Marineris Canyon system. History and nature, Mars the planet. Orbit and rotation. Mars's average distance from the Sun is roughly 230 million kilometers, 143 million miles, and its orbital period is 687 Earth days. The solar day, or sol, on Mars is only slightly longer than an Earth day, 24 hours, 39 minutes, and 35.244 seconds. A Martian year is equal to 1.8809 Earth years, or 1 year, 320 days, and 18.2 hours. The axial tilt of Mars is 25.19 degrees relative to its orbital plane, which is similar to the axial tilt of Earth. As a result, Mars has seasons like Earth, though on Mars they are nearly twice as long because its orbital period is that much longer. In the present-day epoch, the orientation of the North Pole of Mars is close to the star Deneb. Mars has a relatively pronounced orbital eccentricity of about 0.09. Of the 7 other planets in the Solar System, only Mercury has a larger orbital eccentricity. It is known that in the past, Mars has had a much more circular orbit. At one point, 1.35 million Earth years ago, Mars had an eccentricity of roughly 0.002, much less than that of Earth today. Mars's cycle of eccentricity is 96,000 Earth years, compared to Earth's cycle of 100,000 years. Mars approaches Earth in a synodic period of 779.94 days. Earth orbits the Sun the closest to Mars's orbit around the Sun, and Mars' orbit is the second closest to Earth after the orbit of Venus. Therefore, their closest approaches, the inferior conjunctions, are the second closest for Earth after those with Venus, and the closest for Mars to any other planet. The gravitational potential difference, and thus the delta V needed to transfer between Mars and Earth, is the second lowest for Earth and the lowest for Mars to any other planet, while transfers can possibly be optimized with Venus flybys. History and nature, Mars the planet. Moons. Mars has 2 relatively small, compared to Earth's, natural moons, Phobos, about 22 kilometers, 14 miles, in diameter, and Deimos, about 12 kilometers, 7.5 miles, in diameter, which orbit close to the planet. The origin of both moons is unclear, although a popular theory states that they were asteroids captured into Martian orbit. Both satellites were discovered in 1877 by Asaph Hall and were named after the characters Phobos, the deity of panic and fear, and Deimos, the deity of terror and dread, twins from Greek mythology who accompanied their father Ares, god of war, into battle. Mars was the Roman equivalent to Ares. In modern Greek, the planet retains its ancient name Ares, Eris, Rhoeta. From the surface of Mars, the motions of Phobos and Deimos appear different from that of the Earth's satellite, the Moon. Phobos rises in the west, sets in the east, and rises again in just 11 hours. Deimos, being only just outside synchronous orbit, where the orbital period would match the planet's period of rotation, rises as expected in the east, but slowly. Because the orbit of Phobos is below synchronous altitude, tidal forces from Mars are gradually lowering its orbit. In about 50 million years, it could either crash into Mars's surface or break up into a ring structure around the planet. The origin of the two satellites is not well understood. Their low albedo and carbonaceous chondrite composition have been regarded as similar to asteroids, supporting a capture theory. The unstable orbit of Phobos would seem to point toward a relatively recent capture. But both have circular orbits near the equator that is unusual for captured objects, and the required capture dynamics are complex. Accretion early in the history of Mars is plausible, but would not account for a composition resembling asteroids rather than Mars itself, if that is confirmed. Mars may have yet undiscovered moons, smaller than 50 to 100 meters, 160 to 330 feet, in diameter, and a dust ring is predicted to exist between Phobos and Deimos. A third possibility for their origin as satellites of Mars is the involvement of a third body or a type of impact disruption. More recent lines of evidence for Phobos having a highly porous interior, and suggesting a composition containing mainly phyllosilicates and other minerals known from Mars, point toward an origin of Phobos from material ejected by an impact on Mars that reaccreted in Martian orbit, similar to the prevailing theory for the origin of Earth's satellite. Although the visible and near-infrared (VNIR) spectra of the moons of Mars resemble those of outer belt asteroids, the thermal infrared spectra of Phobos are reported to be inconsistent with chondrites of any class. It is also possible that Phobos and Deimos are fragments of an older moon, formed by debris from a large impact on Mars, and then destroyed by a more recent impact upon the satellite. Human observations and exploration. The history of observations of Mars is marked by the oppositions of Mars when the planet is closest to Earth and hence is most easily visible, which occur every couple of years. Even more notable are the perihelic oppositions of Mars, which are distinguished because Mars is close to perihelion, making it even closer to Earth. Ancient and medieval observations. The ancient Sumerians named Mars Nergal, the god of war and plague. During Sumerian times, Nergal was a minor deity of little significance, but, during later times, his main cult center was the city of Nineveh. In Mesopotamian texts, Mars is referred to as the star of judgment of the fate of the dead. The existence of Mars as a wandering object in the night sky was also recorded by the ancient Egyptian astronomers and, by 1534 BCE, they were familiar with the retrograde motion of the planet. By the period of the Neo-Babylonian Empire, the Babylonian astronomers were making regular records of the positions of the planets and systematic observations of their behavior. For Mars, they knew that the planet made 37 synodic periods, or 42 circuits of the zodiac, every 79 years. They invented arithmetic methods for making minor corrections to the predicted positions of the planets. In ancient Greece, the planet was known as Pi Upsilon Rho Epsilon Iota. Commonly, the Greek name for the planet now referred to as Mars was Ares. It was the Romans who named the planet Mars, for their god of war, often represented by the sword and shield of the planet's namesake. In the 4th century BCE, Aristotle noted that Mars disappeared behind the Moon during an occultation, indicating that the planet was farther away. Ptolemy, a Greek living in Alexandria, 209, attempted to address the problem of the orbital motion of Mars. Ptolemy's model and his collective work on astronomy was presented in the multi-volume collection later called the Almagest, from the Arabic Four Greatest, which became the authoritative treatise on Western astronomy for the next 14 centuries. Literature from ancient China confirms that Mars was known by Chinese astronomers by no later than the 4th century BCE. In the East Asian cultures, Mars is traditionally referred to as the fire star based on the Wishing system. During the 17th century AD, Tycho Brahe measured the diurnal parallax of Mars that Johannes Kepler used to make a preliminary calculation of the relative distance to the planet. From Brahe's observations of Mars, Kepler deduced that the planet orbited the Sun not in a circle, but in an ellipse. Moreover, Kepler showed that Mars sped up as it approached the Sun and slowed down as it moved farther away, in a manner that later physicists would explain as a consequence of the conservation of angular momentum. 433 to 437. When the telescope became available, the diurnal parallax of Mars was again measured in an effort to determine the Sun-Earth distance. This was first performed by Giovanni Domenico Cassini in 1672. The early parallax measurements were hampered by the quality of the instruments. The only occultation of Mars by Venus observed was that of October 13, 1590, seen by Michael Maestlin at Heidelberg. In 1610, Mars was viewed by Italian astronomer Galileo Galilei, who was first to see it via telescope. The first person to draw a map of Mars that displayed any terrain features was the Dutch astronomer Christian Huygens. History and Nature, Mars the Planet. Martian canals. By the 19th century, the resolution of telescopes reached a level sufficient for surface features to be identified. On September 5, 1877, a perihelic opposition of Mars occurred. The Italian astronomer Giovanni Schiaparelli used a 22 cm (8.7 in) telescope in Milan to help produce the first detailed map of Mars. These maps notably contained features he called canali, which were later shown to be an optical illusion. These canali were supposedly long, straight lines on the surface of Mars, to which he gave names of famous rivers on Earth. His term, which means channels or grooves, was popularly mistranslated in English as canals. Influenced by the observations, the Orientalist Percival Lowell founded an observatory which had 30 and 45 cm, 12 and 18 inches, telescopes. The observatory was used for the exploration of Mars during the last good opportunity in 1894 and the following less favorable oppositions. He published several books on Mars and life on the planet, which had a great influence on the public. The canali were independently observed by other astronomers, like Henri-Joseph Perrotin and Louis Tholin in Nice, using one of the largest telescopes of that time. The seasonal changes, consisting of the diminishing of the polar caps and the dark areas formed during Martian summer, in combination with the canals led to speculation about life on Mars, and it was a long-held belief that Mars contained vast seas and vegetation. As bigger telescopes were used, fewer long, straight canali were observed. During observations in 1909 by Antoniadi with an 84 cm, 33 in, telescope, irregular patterns were observed, but no canali were seen. History and Nature, Mars the Planet. Robotic exploration. Dozens of crewless spacecraft, including orbiters, landers, and rovers, have been sent to Mars by the Soviet Union, the United States, Europe, India, the United Arab Emirates, and China to study the planet's surface, climate, and geology. NASA's Mariner 4 was the first spacecraft to visit Mars. Launched on November 28, 1964, it made its closest approach to the planet on July 15, 1965. Mariner 4 detected the weak Martian radiation belt, measured at about 0.1% that of Earth, and captured the first images of another planet from deep space. Once spacecraft visited the planet during NASA's Mariner missions in the 1960s and 1970s, many previous concepts of Mars were radically broken. After the results of the Viking life detection experiments, the hypothesis of a dead planet was generally accepted. The data from Mariner 9 and Viking allowed better maps of Mars to be made, and the Mars Global Surveyor mission, which launched in 1996 and operated until late 2006, produced complete, extremely detailed maps of the Martian topography, magnetic field, and surface minerals. These maps are available online at websites including Google Mars. Both the Mars Reconnaissance Orbiter and Mars Express continued exploring with new instruments and supporting lander missions. NASA provides two online tools, Mars Trek, which provides visualizations of the planet using data from 50 years of exploration, and Experience Curiosity, which simulates traveling on Mars in 3D with Curiosity. As of 2023, Mars is host to 13 functioning spacecraft. 8 are in orbit: 2001 Mars Odyssey, Mars Express, Mars Reconnaissance Orbiter, MAVEN, ExoMars Trace Gas Orbiter, the HOPE Orbiter, and the Tianwen-1 Orbiter. Another 5 are on the surface: the Mars Science Laboratory Curiosity Rover, the Perseverance Rover, the Ingenuity Helicopter, the Tianwen-1 Lander, and the Zhurong Rover. Planned missions to Mars include the Rosalind Franklin Rover mission, designed to search for evidence of past life, which was intended to be launched in 2018 but has been repeatedly delayed, with a launch date pushed to 2024 at the earliest, with a more likely one sometime in 2028. A current concept for a joint NASA-ESA mission to return samples from Mars would launch in 2026. History and nature: Mars the planet. Habitability and the search for life. During the late 19th century, it was widely accepted in the astronomical community that Mars had life-supporting qualities, including the presence of oxygen and water. However, in 1894 W. Campbell at Lick Observatory observed the planet and found that if water vapor or oxygen occur in the atmosphere of Mars, it is in quantities too small to be detected by spectroscopes then available. That observation contradicted many of the measurements of the time and was not widely accepted. Campbell and V.M. Slipher repeated the study in 1909 using better instruments, but with the same results. It wasn't until the findings were confirmed by W.S. Adams in 1925 that the myth of the Earth-like habitability of Mars was finally broken. However, even in the 1960s, articles were published on Martian biology, putting aside explanations other than life for the seasonal changes on Mars. Detailed scenarios for the metabolism and chemical cycles for a functional ecosystem were being published as late as 1962. The current understanding of planetary habitability, the ability of a world to develop environmental conditions favorable to the emergence of life, favors planets that have liquid water on their surface. Most often this requires the orbit of a planet to lie within the habitable zone, which for the Sun is estimated to extend from within the orbit of Earth to about that of Mars. During perihelion, Mars dips inside this region, but Mars's thin, low-pressure atmosphere prevents liquid water from existing over large regions for extended periods. The past flow of liquid water demonstrates the planet's potential for habitability. Recent evidence has suggested that any water on the Martian surface may have been too salty and acidic to support regular terrestrial life. The environmental conditions on Mars are a challenge to sustaining organic life. The planet has little heat transfer across its surface, it has poor insulation against bombardment by the solar wind due to the absence of a magnetosphere, and has insufficient atmospheric pressure to retain water in a liquid form. Water instead sublimes to a gaseous state. Mars is nearly, or perhaps totally, geologically dead. The end of volcanic activity has apparently stopped the recycling of chemicals and minerals between the surface and interior of the planet. In situ investigations have been performed on Mars by the Viking landers, Spirit and Opportunity rovers, Phoenix lander, and Curiosity rover. Evidence suggests that the planet was once significantly more habitable than it is today, but whether living organisms ever existed there remains unknown. The Viking probes of the mid-1970s carried experiments designed to detect microorganisms in Martian soil at their respective landing sites and had positive results, including a temporary increase of CO2 production on exposure to water and nutrients. This sign of life was later disputed by scientists, resulting in a continuing debate, with NASA scientist Gilbert Levin asserting that Viking may have found life. Tests conducted by the Phoenix Mars lander have shown that the soil has an alkaline pH and it contains magnesium, sodium, potassium, and chloride. The soil nutrients may be able to support life, but life would still have to be shielded from the intense ultraviolet light. A 2014 analysis of Martian meteorite EETA 79001 found chlorate, perchlorate, and nitrate ions in sufficiently high concentration to suggest that they are widespread on Mars. UV and X-ray radiation would turn chlorate and perchlorate ions into other, highly reactive oxychlorines, indicating that any organic molecules would have to be buried under the surface to survive. Scientists have proposed that carbonate globules found in meteorite ALH 84001, which is thought to have originated from Mars, could be fossilized microbes extant on Mars when the meteorite was blasted from the Martian surface by a meteor strike some 15 million years ago. This proposal has been met with skepticism, and an exclusively inorganic origin for the shapes has been proposed. Small quantities of methane and formaldehyde detected by Mars orbiters are both claimed to be possible evidence for life, as these chemical compounds would quickly break down in the Martian atmosphere. Alternatively, these compounds may instead be replenished by volcanic or other geological means, such as serpentinite. Impact glass, formed by the impact of meteors, which on Earth can preserve signs of life, has also been found on the surface of the impact craters on Mars. Likewise, the glass in impact craters on Mars could have preserved signs of life, if life existed at the site. Human mission proposals. Several plans for a human mission to Mars have been proposed throughout the 20th and 21st centuries, but none have come to fruition. The NASA Authorization Act of 2017 directed NASA to study the feasibility of a crewed Mars mission in the early 2030s. The resulting report eventually concluded that this would be unfeasible. In addition, in 2021, China was planning to send a crewed Mars mission in 2033. Privately held companies such as SpaceX have also proposed plans to send humans to Mars, with the eventual goal to settle on the planet. The moon Phobos has been proposed as an anchor point for a space elevator. History and nature, Mars the planet. Viewing from Earth. The mean apparent magnitude of Mars is plus 0.71, with a standard deviation of 1.05. Because the orbit of Mars is eccentric, the magnitude at opposition from the Sun can range from about minus 3.0 to minus 1.4. The minimum brightness is magnitude plus 1.86 when the planet is near aphelion and in conjunction with the Sun. At its brightest, Mars, along with Jupiter, is second only to Venus in apparent brightness. Mars usually appears distinctly yellow, orange, or red. When farthest away from Earth, it is more than 7 times farther away than when it is closest. Mars is usually close enough for particularly good viewing once or twice at 15-year or 17-year intervals. As Mars approaches opposition, it begins a period of retrograde motion, which means it will appear to move backwards in a looping curve with respect to the background stars. This retrograde motion lasts for about 72 days, and Mars reaches its peak apparent brightness in the middle of this interval. The point at which Mars's geocentric longitude is 180 degrees different from the Sun's is known as opposition, which is near the time of closest approach to Earth. The time of opposition can occur as much as 8.5 days away from the closest approach. The distance at close approach varies between about 54 and 103 million kilometers, 34 and 64 million miles, due to the planet's elliptical orbits, which causes comparable variation in angular size. The most recent Mars opposition occurred on October 13, 2020, at a distance of about 63 million kilometers, 39 million miles. The average time between the successive oppositions of Mars, its synodic period, is 780 days, but the number of days between successive oppositions can range from 764 to 812. Mars comes into opposition from Earth every 2.1 years. The planets come into opposition near Mars's perihelion in 2003, 2018, and 2035, with the 2020 and 2033 events being particularly close to perihelic opposition. Mars made its closest approach to Earth and maximum apparent brightness in nearly 60,000 years, 55,758,006 kilometers, 0.37271925 AU, 34,646,419 miles, magnitude minus 2.88, on August 27, 2003, at 9:51 and 13 seconds Universal Time Coordinated. This occurred when Mars was 1 day from opposition and about 3 days from its perihelion, making it particularly easy to see from Earth. The last time it came so close is estimated to have been on 12 September 57,617 BC, the next time being in 2287. This record approach was only slightly closer than other recent close approaches. Optical ground-based telescopes are typically limited to resolving features about 300 kilometers, 190 miles, across when Earth and Mars are closest because of Earth's atmosphere. History and nature, Mars the planet. In culture, Mars is named after the Roman god of war. This association between Mars and war dates back at least to Babylonian astronomy, in which the planet was named for the god Nergal, deity of war and destruction. It persisted into modern times, as exemplified by Gustav Holst's orchestral suite The Planets, whose famous first movement labels Mars the bringer of war. The planet's symbol, a circle with a spear pointing out to the upper right, is also used as a symbol for the male gender. The symbol dates from at latest the 11th century, though a possible predecessor has been found in the Greek Oxyrhynchus papyri. The idea that Mars was populated by intelligent Martians became widespread in the late 19th century. Schiaparelli's Canali observations combined with Percival Lowell's books on the subject put forward the standard notion of a planet that was a drying, cooling, dying world with ancient civilizations constructing irrigation works. Many other observations and proclamations by notable personalities added to what has been termed Mars fever. High-resolution mapping of the surface of Mars revealed no artifacts of habitation, but pseudoscientific speculation about intelligent life on Mars still continues. Reminiscent of the Canali observations, these speculations are based on small-scale features perceived in the spacecraft images, such as pyramids and the face on Mars. In his book Cosmos, planetary astronomer Carl Sagan wrote, "Mars has become a kind of mythic arena onto which we have projected our earthly hopes and fears." The depiction of Mars in fiction has been stimulated by its dramatic red color and by 19th-century scientific speculations that its surface conditions might support not just life but intelligent life. This gave way to many science fiction stories involving these concepts, such as H.G. Wells' The War of the Worlds, in which Martians seek to escape their dying planet by invading Earth, Ray Bradbury's The Martian Chronicles, in which human explorers accidentally destroy a Martian civilization, as well as Edgar Rice Burroughs' Barsoom series, C.S. Lewis novel Out of the Silent Planet, 1938, and a number of Robert A. Heinlein stories before the mid-60s. Since then, depictions of Martians have also extended to animation. A comic figure of an intelligent Martian, Marvin the Martian, appeared in Haredevil Hare, 1948, as a character in the Looney Tunes animated cartoons of Warner Brothers, and has continued as part of popular culture to the present. After the Mariner and Viking spacecraft had returned pictures of Mars as it really is, a lifeless and canal-less world, these ideas about Mars were abandoned. For many science fiction authors, the new discoveries initially seemed like a constraint, but eventually the post-Viking knowledge of Mars became itself a source of inspiration for works like Kim Stanley Robinson's Mars trilogy. My name is Arya. Please like, share, subscribe and hit that notification bell so you can be the first to be notified whenever we post. You won't regret it.